So welcome everybody. I would like to talk about the master solution of this exam here, and it's a 3-hour exam. In the first part, we solved some multiple choice questions, and this solution goes to a different video. So let's start with problem number 2, regression analysis, Okun's law for one age cohort in Italy. And we talked already about Okun's law for Germany, US, and Denmark. And now we would like to talk about the relationship in Italy for the oldest age cohort. So the age cohort 55 to 64. When you look at this graph, you hardly can see the Italy line. So more or less, it will be the case that you can expect a slope of minus 0.1, something like that. So this will be the slope for Italy. So let's switch to the Excel file and analyze this kind of stuff. So we have the unemployment rate in Italy for the oldest age cohort from 1983 all the way down to 2011. And then we also have the growth rate of GDP. So in the first step, we have to compute the change of unemployment rate. Change unemployment rate in this column, and this is equal to cell number C6 minus cell number C5. Here we have the change in the unemployment rate. Let's copy all the information down. You can make a double click here, and then the formula is copied all the way down. Then we have to mark all the data. So this data is marked now, and then we go to Einfügen, Insert, XY scatter diagram, Punkt XY diagram, like this icon here. We take the first one, and then we should include some labels for the horizontal axis, vertical axis. We should include a regression equation. So we take layout number 9 from this fast layout menu, layout number 9, third column, third row, and then everything is fine. Let's format this a little bit. I will augment it, make it a little bit larger. Okay, horizontal axis. This is growth rate of real GDP. And on the vertical axis, this is a change in the unemployment rate. And we are done. Perhaps we should cross-check this point. This is the year 2009, where we have a negative growth rate of minus 5.5% of real GDP. And there, the unemployment rate increases by 3 percentage points from 3.1 to 3.4. Yes, the growth rate of real GDP is displayed on the horizontal axis, and the change in the unemployment rate, this is displayed on the vertical axis. Always make a cross check here. The slope is a negative 0.04, so the regression line has a negative slope, and the intersection of this regression line with the vertical axis is in the positive range, here at the level of 0.1. Okay, let's switch back to the document. We are done with the regression. We are copy pasting the information to the Word document, and now we have to answer the following question. How large is the slope of the Okun relationship? It's a negative 0.04. and the intercept is positive, like positive 0.11. We find this information in our scatter plot, and then we should compare the results to Germany, USA, and Denmark. And here, like the third alternative is right. The slope parameter is in the same range compared to the other three countries. Nothing is special in Italy. So the slope parameter for Italy is negative. It's not positive. And the slope parameter for Italy is negative, while for other countries it was positive. Answer 2 doesn't make sense. So answer 3 is it. Yeah, let's talk about problem number 3. We have an investment shock in the ISLM model. So chapter 12 is relevant. ISLM model. Equations are given here. The managers are cutting back investment. So we need to know that this part belongs to the investment function. And we have a negative shock related to the autonomous component of money, autonomous component of investment. So B0 decreases. And then you directly see that the IS equation is affected. IS equation is affected in a negative way, so the IS curve will shift to the left. This is important for like part B, for scenario B, like for the second part when we perform a graphical analysis of the shock. So like first we have to label all the graphs. This is a blue scenario, like are the interest rate on the vertical axis, horizontal axis, it's GDP. This is the LM curve, LM0 curve. It is upward sloping, and the IS curve is downward sloping in the initial equilibrium A, with RA the interest rate level, YA the GDP level. So the blue lines are important for part A, where we should label all curves, axes, and the equilibrium. The graph is displayed like on the next page. So the blue lines are important. Now we have to incorporate the shock. Scenario B in red ink. The IS curve shifts to the left. It is the IS1 curve. The curve shifts to the left because B0 decreases. And then we find a new equilibrium in point B. RB is the interest rate, YB is the GDP level, so the economy ends up in a recession. So we are done with the second part. Let's check part 3. Let's assume that the central bank does neither like booms nor recession because of the fluctuations of the unemployment rate. How could the central bank react in order to stabilize the output on the level YA? Include the reaction of the central bank in your graph. So first there was a negative shock, and now it is the case that the central bank has to shift like the LM curve to the right. The central bank has only one policy tool. The central bank can only increase money supply, and the LM curve shifts to the right so that the GDP level is on the same level as before. So YA is equal to YC, and the interest rate drops even further to the level RC. So the yellow part, this is related to scenario C. It's very important that the central bank is acting. The central bank has only money supply as a policy tool. The central bank cannot use government spending or taxes because this is a government who decides on government spending and the taxes. So like this is the solution for part A, B, and C. Let's check the follow-up questions. In the ISLM model, like the goods prices are constant because the goods prices are exogenous. So during the adjustment process, the goods prices are constant in the ISLM world. Then what is the relationship with respect to the interest rate when we compare the two equilibria in A and B? Like here was a mistake in the exam, so I corrected this mistake. And the interest rate dropped. RA is larger than RB. In order to counter the effects on the good price, the government should no action required by the government because, as I mentioned in the first question, like the goods prices are constant, goods prices do not change because they are exogenous. So no action required with respect to the goods price. Okay, let's switch to problem 4. This is related to chapter 6. An earthquake occurs, and this affects the IS model in an open economy setting because of the fact that we are in chapter 6. You also get some information from the class so that you know what's going on with respect to the equations. We should perform this analysis in the open economy that an earthquake destroys the capital stock and the labor force. So we have a shock with respect to the GDP level. GDP will decrease, so the y variable will decrease. So first of all, like we have to label like all the curves. The blue scenario is the initial scenario where like the interest rate in the domestic economy RA is equal to R star. The downward sloping investment curve is valid and the vertical line represents savings of the society. So in the initial scenario, it is the case that savings in A is equal to investment in A. Net exports are equal to 0 because saving is equal to investment. When the earthquake occurs, it is the case that here private saving is affected because like GDP decreases, so the saving possibilities are changed, or the saving possibilities have changed, and therefore like the saving curve will shift to the left. This is performed like in this graph. The saving curve shifts to the left because capital and labor decreases and GDP decreases. So in a closed economy setting, we would end up in the intersection of the new saving curve and the investment curve. So we would end up in A prime. But this point is not relevant in the open economy setting. In the open economy setting, the domestic interest rate is equal to the foreign interest rate. So RB is equal to R star. So it is the case that investment does not change because the interest rate does not change. So IB is on the same level as IA. So investment does not change. Saving decreases from the level A to the level B, and the difference between saving and investment, this is like net exports. The country has a trade balance deficit in situation B, so the trade balance is negative because we are investing more than we are saving. Yeah, let's go back to the follow-up questions. So how is GDP affected? GDP is down because capital and labor decreases, and then also like the Y variable is down. How is national savings affected? SB is smaller than SA, so saving decreases. What about investment? Investment does not change because IA is equal to IB. Investment does not change because the interest rate does not change. RB is equal to RA in an open economy setting. So the second answer alternative is right. I is constant, does not change. What about the domestic interest rate? Domestic interest rate is not affected. RB is equal to RA. R is constant because of the fact that the foreign interest rate R star determines the domestic interest rate level in A and B. Great, so we are also done with this part. Let's switch to the next question. So you are a manager of one firm, like you are operating in the bar and you are checking the inventory. So capital is equal to 400, labor is equal to 4, the beer prices are equal to 30, and the labor unions have fixed the wage rate at the level of 60. This is a production function. So the assumptions are as follows: that capital is fixed and cannot be adjusted in the short run. Only labor is flexible, only labor is variable, and you have to do something and check whether labor is optimal. In the first part, you should calculate the marginal productivity of labor. Let's do that. We have to differentiate the production function with respect to L in the following way, like we take the exponent, write the exponent in front of the expression, and reduce the exponent by 1 unit. So we end up at 0.5 k to the power of 0.5 L to the power of minus 0.5. Hence, this implies 0.5 k to the power of 0.5, and then L to the power of 0.5 goes into the denominator of this relationship because of the fact that we had a negative sign here. So this goes in the denominator. Then we plug in the numbers we have. So k is equal to 400, so we should derive the square root of 400, which is equal to 20, and then the square root of 4 is equal to 2. So 0.5 times 20, that's equal to 10, divided by 2, so the marginal productivity of labor is equal to 5 beers per hour. So when you hire one additional worker, then this worker can create like 5 beers per hour. Describe verbally in 3 bullets whether you hire more or less labor. So when you hire one additional worker, he can create like 5 beers per hour, which can be sold at the price of 30 Danish krona. So the revenues would be up by 150 Danish krona. And then we have to incorporate the wage rate. Wage is a cost component. So when you hire one worker, it will cost 60 Danish krona. The costs are equal to 60. Then when it comes to the profit function, profit is equal to revenues minus cost. So 150 minus 60 is a positive 90. So when you hire one more worker, the profit is up by 90 Danish krona, 150 minus the 60. We should also compute the optimal number of workers. So this is performed here. The optimality condition is that the marginal productivity of labor is equal to the real wage. We have computed already the marginal productivity of labor. It is 0.5 times the square root of 400 divided by the square root of L. L is the unknown variable we want to find out, and the real wage is equal to the nominal wage of 60 divided by the price of 30. So the real wage is equal to like 2. When we divide by 2, we get 10 over 2 on the left-hand side. We also multiply through by the square root of L so that this part goes to the right-hand side. So the square root of L is equal to 5. So L is equal to 25. So we know that you have to hire labor because right now labor is equal to 4 and the optimal amount of labor is equal to like 25. Okay, follow-up questions are here. How large is the real wage after optimization? Like the real wage does not change. It is 60 over 30, like 2 beers per hour. How large is the marginal productivity of labor in the optimum? Of course, like this is our optimality condition. We know that the real wage is 2 beers per hour. So the marginal productivity of labor has to be equal to 2 beers per hour. We can also compute that. Like the marginal productivity of labor is given by 0.5 times the square root of 400 times the square root of the optimal number of labor units, like 25. So it's 0.5 times 20, which is equal to 10. 5 in the denominator, so a marginal productivity of labor in the optimum is indeed equal like to 2 beers per hour. How large are the revenues in the optimum? In order to answer this question, we have to, in a first step, compute how many beers are produced. And here our production function helps. So we have to take the square root of 400 times the square root of 25, which is equal to like 20 times 5. So 100 beers are produced in our bar. And when we multiply through 100 beers by the beer price of 30, so 3,000 Danish krona, this is equal to the revenues in the optimum. That's it with respect to this exam. In case that you have questions, please send me an email or comment in YouTube. Feel free to comment, ask your questions. Thank you very much. Have a nice day. Bye-bye.